I'm Anil Kumar, and now we will explore how to find whether the given data represents a linear, quadratic, or neither of these functions. Question here is, explain the steps which can help to decide whether data for a function are linear, quadratic, or neither. So we'll kind of make a flowchart. We can decide whether the data represents a linear function, quadratic function, or neither based on finite difference. So what you need to do is you need to calculate finite difference, right? So if you calculate finite difference, then you can figure out whether the data represents linear, quadratic, or neither type of function, right? Do you remember what is finite difference? So I'll make a flowchart, right? So let's say this is the operation we need to perform on the data. Finite difference. What is finite difference? Finite difference is we are given in the data x and y values. So you need to find y2 minus y1, right? And then check all the values. If they are constant, then it means linear, right? So find the finite difference. Then you have to check whether it is constant or not, correct? If it is constant, then it's a linear function. Is that okay? So then you check whether the data represents a constant finite difference or not. So constant means same value, right? So in case it is constant, then what? Then this is the first finite difference, correct? First time when you find the finite difference, and if you get the data constant, then it means that it is a linear function, correct? So what we can do is, we can see whether it is yes or no. If the data is constant, that is the first finite difference, in that case we know that it is going to be a linear function, right? So let me write down here linear function. Now in case it is not constant, then what do you do? One thing is very clear, if it is not constant, it is not linear, right? So we know one thing, that if it is not constant, it is not linear. Okay, so let me write down first, it means not linear. Okay, then what do? We repeat the process. We find the second finite difference, correct? So at this stage, you again calculate finite difference, right? So then again calculate finite difference, and this time this is going to be the second finite difference, right? So we say calculate second finite difference. Let me write it in short. Now when you calculate second finite difference, then you may get it constant or you may not get it constant, correct? So again we have to take a decision based on whether it is constant or not, right? So then again decide whether it is constant or not, right? So there are only two possibilities, that this second finite difference may be a constant or it may not be a constant, correct? So if it is constant, then it is quadratic, otherwise it is neither, correct? So that is how you can figure out whether the given data represents a linear function or quadratic function or what, right? If it is constant, it is quadratic. If it is not constant, is neither, right? You can of course continue this process, and if finally you get it constant, then depending on which difference was constant, we can get to know what type of polynomial the data represents, right? If we get fourth finite difference constant, then it means it is a polynomial of degree 4, right? But in any case, these are the steps which can help you to figure out whether the given data represents a linear quadratic function or neither of them, right? So let's go through them once again. So whenever you are given a data, then calculate the finite difference. We are calling this as the first finite difference. If the first finite difference is constant, then the function is linear. Otherwise, we'll continue this process. It is definitely not linear. Then again calculate the finite difference. This is the second time we are doing it, and so we are calling it second finite difference. If second finite difference is constant, then this is a polynomial of degree 2, which we call quadratic function. If it is not constant, then it's neither linear or quadratic, right? So we'll leave it for the time being here. I hope that helps. Thank you and all the best.